To do any kind of inference procedure ever on the AP exam, you've got to use the 4C method of inference. Now, let me also clarify, the 4C method for inference, Sanaya, are you for real?
I'm sorry, it's not my hair. My braid's tight.
Take care of that outside class, come on. We got stuff to learn.
I'll pay attention.
Okay. The 4C method of inference, that is, again, I've said this before, if you look in the book, it's also called state, plan, do, conclude. It's just to help you remember the 4 things you need to really do every time you do this. And so I do want to point out, look around the room, we start out pretty well. One sample T interval, well, looking over here, one sample T interval, right, it is a T interval, it is one sample. What I do want to remind you of always though, is these intervals that we are calculating, yes, you will definitely want a calculator today, but these intervals that we are calculating, what are those intervals?
Plausible values.
Plausible values for the what?
Sample.
For the
Population
what?
mean.
For the population mean, for parameter, period, right? It could be a mean, it could be a proportion. We don't go into an AP stats, but you could do it for even standard deviations, right? Like you can do, and we'll even do it for slopes of least squares regression lines. You can do these 1 sample intervals, 2 sample intervals for any type of parameter, okay? So we are trying to create an interval for a parameter, in this case means. So notice after you identified the type of procedure that you have chosen, you need to identify the confidence level. You got to look at mu, or define what your parameter is. That all goes inside of the choose, okay? Also, it was on the, oh no, it's not on this sheet. It's on the other side maybe? Right? So remember, there's our 4C method. That's what I'm always looking for in general. And it changed a little bit from a test to a confidence interval, but that's pretty good. After we choose our procedure, what do we need to do? Check our conditions, okay? And so checking conditions, what's the first one that we always need? Some type of random. In this case, we have a random sample. Why is a random sample important? It allows us to make an inference about the population, right? I only have 15 households, but I want to make a prediction about all the households in that community. So I've got a random sample. What comes after random? 10%. Remember, when sampling without replacement, which do we want to get the same household more than once? No. So when sampling without replacement, we need our sample size to be what?
Less than
10% of the population.
Less than 10% of the population. Now, do we actually know what the size of this population is?
No.
No, in that case we would just say, hey, we assume 15 is less than 10% of all the houses in that community, okay? Last one, I need y'all to remember this because in proportions we did large counts conditions. In means, if the population mean is approximately normal, then our sampling distribution is as well. If we satisfy the central limit theorem, or this new one that we've just recently talked about, what is the last condition really about though? What's approximately normal? The sampling distribution. Remember this, the whole thing is about the sampling distribution being approximately normal. First off, when we talk about this community, do we know that the average number of pounds of garbage they produce is approximately normal? No. We don't know about the population. Do we have a large enough sample size to satisfy the central limit theorem? No. Nope. So what do we have to do in this case?
Assume normality.
Yeah, outlier skewed, heavy skewness.
So like when I look here, just eyeballing it, does it look like there's any outliers?
Nah.
No. Does it look like there's any heavy skewness?
Nah.
No. So it is reasonable to believe the sampling distribution is approximately normal. Notice the language I used there was because that sample shows no skewness, or no heavy skewness and no outliers, it is reasonable to believe the sampling distribution is approximately normal. You will never see me just say random check. You will never see me say approximately normal check. You got to speak to what is actually being said there. So keep that in mind when you're doing these things. Now after all that, we need to calculate. And I know Serena was saying, hey, Mr. Kinney, I'm not sure about the calculate. Is that what you were saying? On the calculator,
Yeah.
specifically? So remember, if you make a, I don't know why that is no longer connected. if you make a calculator page, which I've already, did I already send out the file?
Yes.
Okay, so you can just add a calculator page. So if you so go back to the thing, hit Control and then Dock. It'll allow you to create a new page, add a new calculator page. All right, if I want to run a hypothesis test, where am I going to go? Menu. And statistics. And there's stat test down there.
Yeah.
What?
I already.
No, you're right, confidence interval. That's what I said.
Oh,
Yep, my bad. That's why you name the procedure, and you go back to the name of the procedure from the beginning. What type of interval are we doing? A T interval, right? One sample T interval helps me remember to go to T interval, not hypothesis test. Now, I need y'all to remember, I could look at the raw data, but right now, do I have data or do I have statistics? I have statistics that I'm going to be putting in. Okay?
Oh, no, Sunday.
And so notice right here, you literally, Serena, just put in the statistics. What's our sample mean?
59.5.
59.5?
Yep.
What does SX stand for again?
Standard deviation.
Which standard deviation?
Sample.
Sample standard deviation, what is that?
27.2.
What's my sample size?
15.
15.
And
By the way, just pausing for a second, what does that mean my degrees of freedom is?
And minus
one.
15.
N minus 1, so 14, right? So my sample size 15, my degrees of freedom would be 14, and what's my confidence level?
99. So you put, wait,
What? You just fill in what it asks for.
so you have to do the data thing?
No, this is statistics. Data is when you have the raw data points. We have statistics. Remember, X bar is a statistic estimating mu. S is a statistic estimating sigma. So we have statistics, not the raw
I don't
data.
think I was paying attention. I wasn't paying attention whenever you clicked like. Okay, so we're in a new table. Then what do we do?
Oh, I went to a calculator page.
Oh. Okay, so menu.
I had Control Dock and I did a calculator page
Okay,
to run a test.
Menu,
or an
I've had
interval.
that thing on the menu statistics. Then what?
the confidence intervals.
Okay.
T interval
It says data. Oh, and then you change the data input method.
to
Okay.
statistics. Yep.
Okay, I see. Thank you.
Mhm. And there's all my stuff.
Sweet.
Notice it does spit out my degrees of freedom. It spits out the lower part, the upper part, and so,
What do
I'm
we
just-
do?
huh?
Oh yeah, that's on me. I put standard error stuff, standard sample, standard deviation.
Oh.
So that's on me.
No,
Where
no,
did
no,
you
like
get
for
your
our actual mail.
4.14 from?
Oh,
Oh, that was our degrees of freedom. Or like the thing.
Look again, what's your degrees of freedom?
14.
And what's your confidence level?
Oh, I did
99.9.
99.9.
Yeah.
There you
Okay.
go, so be careful, yeah.
Whoops.
That was the issue, so, be careful, it's a 99% confidence level, it's a 14 degrees of freedom, so what was the T supposed to be?
2.977.
2.977?
That's
is what our
weird.
T score value was?
It went at 1.9% and then like the whole thing shifted by 8.
Well, you gotta remember, it went from 2.77, or 977 to 4.14, you increased the interval width by over 75, or over 25%. No, over 33%.
Nerd.
So, that's what happened there. Alright, sorry, numbers. They're tough sometimes. Here's what I wanna point out though, and I need y'all to hear me on. Couple of things. So this is my interval with 99% confidence. The interval from 38.6 tons, is that what it is? Pounds?
Pounds.
38.6 pounds to 80.4 pounds captures the true mean weight of garbage. Is it all of all households or per household?
Per household.
Per household. For all, it is average weight. It's mean weight of garbage for each household in the community. Yeah, we should probably say it that way, right? Because it's
all households.
yeah. We're
Like-
estimating it for all households, right? But there's no way that all households together only are getting 80 pounds of garbage. That's maybe 80 pounds per house.
The weight of garbage. Mean weight of.
I thought it was like calculating each for every single household in the neighborhood.
Well, it's a mean weight, right?
Yeah.
Yeah.
So
I mean, you can say for all.
each,
I would say for each. It still has Alright, anyways, here's what I need to ask, and this is what's important. Does this provide evidence against the average weight being 50 pounds per household?
No.
Why not?
No,
Hey,
because it's a
not-
plausible value.
We need to remember what a confidence interval is. These are plausible average weights. Okay? Does it provide evidence that the mean weight is 50 pounds?
No.
Why not?
Because it's not definite, there's
Yo,
variability.
quit pulling the Jaden. He was talking.
That is Jaden.
values, not.
Is what?
No.
We're not bio anymore, so now.
My bad.
Because it's like a set of values, not like a single value.
So it's not a single value. Now, is 50 a plausible value?
Yeah.
But are there other plausible values?
Yeah.
So that doesn't tell me that the mean is 50. Could the mean be 90 pounds per household?
Well, it's possible.
It's possible, but is it plausible?
No.
Would this be enough evidence that our mean is less than 90?
Sure.
Yes. We need to remember that these are all the plausible values. So a value, this capturing a specific value doesn't mean it's for sure 50, but this is very strong evidence that it is not 90. We need to recognize that. That is my plausible values. If a value is inside of it, it's plausible. If a value is outside of it, it is not plausible. But another thing to remember is we never prove the null hypothesis. It's just evidence against, or for the alternative is what we're looking at. All right, picking it up from here. So we went through this yesterday on the calculators. We're going to come back to this at the end of today. And I'll explain why. Well, we're going to use that data. That's why I sent it out to the calculators. Actually, I got a little ahead of myself. My bad. Sorry.
Chipsters.
Huh?
What the heck is a chipsters?
Oh, what?
Never mind.
Okay. What's up, Lon?
When you say plausible, does that mean like likely to happen?
Likely. It's different than possible. Because here's the thing. Is 90 pounds possible?
Yeah.
Is it likely, though? No.
I mean, if
When we
Peter
say
was
plausible, it is a possible value that is likely to happen. Yes, and I.
Peter was
Can you what?
Print me the sheet.
I gave you a whole packet.
No, 'cause
Yeah,
he
they're
can't hear,
Mr.
he's
Davis, but
deaf.
he didn't come today, so I couldn't go
Big
get it.
old ears
Huh?
that he can't
They're
hear.
Mr. Davis's class, but I can't get it because he's not here today.
We'll just have to follow along. Well, we're also moving past this right now. The only thing I want to point out is if we're doing a confidence interval for a mean, for a single mean, Serena, what's the 4 things we got to do?
4C method of
Yeah, we got to choose. We've got to check. We have to calculate. And we've got to conclude. Now, with that in mind, when we say choose, we got to choose the method, the procedure, right? Method, procedure, whatever, right? So we had a 1 sample t interval for a population mean, okay? So procedure there. What else do we always want within that choose section?
Confidence.
We need our confidence level. Identify that. Choose your confidence level.
Then what the true mean is.
So define your
Parameter.
parameters. Guys, y'all hurt me yesterday with how little we defined parameters.
Are we getting that back?
Not today, but yes. Someone still has to take it.
Wait, do we get to see it or like?
You can stay a few minutes after class if you want to look at it.
Oh my God.
You gotta define your parameters. Check. What do we need to check?
Random.
Random condition. It's gotta be a random sample or random assignment.
10%.
10% condition. Only when we're what though? Sampling without replacement. And then what's the last one?
Approximate normality.
CLT.
Be more clear with approximate normality. It doesn't have to be CLT.
Just anything for real.
The sampling distribution is
approximately.
approximately normal. Remember with proportions, there was only one way to check that. With proportions, you had to check the what? Large counts condition, okay? But with means, there's a few different ways. If the population is approximately normal, the sampling distribution is approximately normal. Don't you dare call something normal. It's approximately normal, okay? Or if it doesn't, if we don't know about the population, if my sample size is what?
Sufficiently large.
Sufficiently large, I can use the
CLT.
central limit theorem, but what if I don't satisfy the central limit theorem either? So we just looked at, if that sample does not show strong skewness, then it is reasonable to believe the sampling distribution is approximately normal. So make sure we have a new check if n isn't large enough. That new check is if sample isn't heavily skewed or show outliers. By the way, do you know where you could find this information as well if,
Textbook,
maybe you missed a day of
probably.
class? Huh?
Textbook.
YouTube.
It's 100% on YouTube, it's 100% in the textbook too. Like, it's there. It's in a box. I reread it recently because I was bored out of my skull during an unspoken thing. Calculate. Huh?
Were you reading it during the ACT?
No!
He
I
was
would
on
never-
that. He was
no.
on that toilet. Just say that.
What?
Yeah, he definitely was. He definitely was.
There's no shot I would ever,
Why would you
ever
bring a
bring it up
textbook
like
to the
that.
toilet, bro?
Yeah, that's weird. Alright, calculate.
Who would do
Hey,
that?
guys, right here. General form. What's the general form for every interval? Statistic, plus or minus.
CD times.
So our critical value, see, this is why we use critical values. It's not just z, it could also be t, when we're talking about means, times the standard error. All that together is called my
Margin of error.
margin of error. When we're dealing with means, it's going to be, what's my statistic? X bar plus or minus, critical value is t star, t critical value, times.
Sample standard deviation over the square root.
All that's on the formula sheet, okay? And then we conclude, what does that confidence interval tell us? So make sure you have those ideas. All right. By the way, there are lots of homework problems. I don't think I've put the solutions up yet. I will soon. But there are lots of homework problems. If you're like, man, I really need to practice this crap, then do it. I'm here to help you. I'll put those solutions up. You can ask questions. You can come before school, during school. I got an intern for another month, so you can come while she's here, and I can work with you. She can work with you, whatever. But we got to get there. We got a test, AP exam coming up. All right. So, which cookie has the most chips? So, Ms. Kowalski was very generous because I actually totally forgot to buy these. And by generous, I'm going to pay her back. But she just last block made a run to Publix. Don't tell anybody.
You aren't allowed to
YouTube,
leave campus.
Don't. I was here.
I'm snitching.
I'm
They're right here. All right. So, is there a difference in the number of chocolate chips in Chips Ahoy cookies versus the number of chocolate chips in an off-brand cookie? Now, granted, we decided not to go off-brand because Publix was available.
Publix cookies are the best!
Actual Publix cookies. So I'm hyped about this. If you never had a Publix chocolate chip cookie, it's a good time. All right.
I'm so happy.
So, here's what we're gonna do. Every person, because otherwise we wouldn't have a ton of data, right? So this says, where was it? Oh, it doesn't say it up here yet. But it does say due to the factory processes, we can assume the population distribution of the number of chips are approximately normal and that the samples are random. That is actually a fair thing to say. And so we're gonna rock with those conditions being satisfied. So what are we gonna do? Half the students in the class get a Chips Ahoy cookie, except we have 6 of us, not the normal 9. The other half gets an off-brand cookie. We're gonna dissect the cookie, record the number of chocolate chips.
It's like apes, bro.
Yeah. But not like with frogs. So just dissect the cookie, record the number of chocolate chips on the board, okay? So what I'm actually gonna have you do, we're not gonna use StatsMedic because we got Inspire, so we don't need that. What we are going to do is each of you is gonna get a Chips Ahoy, and each of you is gonna get a Publix cookie. And you're going to write your number of chocolate chips up here. So Chips Ahoy and Publix.
If Publix doesn't win, I'm going to crash out.
I know, I'm going to be a little sad. So what's a question though that we could ask about the chocolate chips in these 2 cookies?
Huh?
What's the question that we're going to ask?
Which there are higher amount of chocolate.
So like right away, which one has a higher amount of chocolate chips? Except we're in a stats class. We need better language than that.
Is what the
The
difference in
true
proportions
difference.
of...
What's the true difference in the
Oh, it's
mean
amount
number of...
chocolate chip
chips
cookies.
inside a chocolate chip cookie.
That's only one population. Why do we need a true difference then?
Of Chips Ahoy.
For Chips
Chips
Ahoy
Ahoy and Publix.
and Publix. Okay, there we go. Okay.
Publix on top?
So those are things that we need to notice and keep in mind. We are going to test this theory. What is the true amount? So we're looking for a confidence interval here. If we had a hypothesis that they were different, then we could do a hypothesis test. That might be a later thing. So each person come grab off random Chips Ahoy cookie.
Oh,
And up, Publix
slow down.
cookie.
Bruh.
Ms. Kowalski, if you want to take a break and join us in dissecting, you can as well. Go ahead and grab them. I'll grab some paper towels. I'll be right back.
I know we're just sticking our grubby little paws in them.
I use my nails actually.
That's
Oh.
even worse.
Frida.
Yeah, there's a reason why
you were putting it in your ear earlier.
Oh.
Girl, I only touched one cookie.
You gotta go. I'm sorry.
Hey, listen, I'll be honest with you, there's a reason
Why are they the same size?
There's a reason why DCH policy says you don't need to have long nails, because bacteria grows under there.
I learned
You see
that.
that?
I learned that last year.
I learned that last year when I was.
Now somebody.
Fuck you too.
Oh, you get one to each one.
Oh, I didn't know.
Oh, you should.
Yeah, so okay, actually I'm gonna ask you, speaking of that, about the $100 nails.
Dude, I really want to eat this.
Oh, Miss
I know, I watched it happen.
Where was I?
You ate me in
I don't know
the.
where you're
The
at.
hard
Where
ones.
did this happen?
These are gonna be hard to
Oh,
dissect.
so during enrichment,
I like the chewy ones.
she made a mistake.
I like-
Alright guys, I need y'all to dissect your cookies
Oh, God.
The bell
And
rang and I
How are we gonna
find out how many chocolate chips are in each of the
What do we
cookies.
dissect?
It was about 10 on one, 10 on two.
Say again.
And
I don't have
and
proper
I come
surgical
back and she
instruments.
leads class from
Get
Mississippi.
good.
I didn't tell you like that.
Like,
Tear it apart.
Scalpel or
And she
something.
comes back.
Thank you.
Come on now.
And just treat me.
Sad.
Ms. Kowalski, I do prefer
Crunchy. I
Oreos.
don't know
Okay.
how crunchy they are.
Alright, so ladies and gentlemen, here's what I need y'all to do. What do we still need to calculate?
Can we take a field trip to the restaurant?
No.
The mean.
We need the means, we need the standard deviations, we need the sample sizes. So what are you gonna have to do to find those things?
Put it in a
Add them all up and then
calculator.
divide it.
No!
The
What?
calculator,
Well, then Mr. Kenny, I don't know.
Oh, you use the tape guide.
I'm gonna use a calculator, yeah!
Oh,
Right.
you're so smart.
No, I'm lazy. And also I got technology,
But when we don't
So you
find
finally
paper,
admit
it's
it.
easy.
But let me be
How about you
And-
make it,
and
then you
then
send it
take
to
the
us?
force through the-
You gotta learn how to be the right type of lazy. Lazy where you don't get crap done is a bum
Like
lazy.
Jaden.
I didn't say a name. Lazy where you use your resources is the best kind of lazy.
Isn't there a
Like
quote?
Bill Gates.
Yeah, isn't there a quote about
Bill
that?
Gates is really killing me.
Alright, put your data in.
18,
Bear with me.
17, well, 19,
Man, you know, smart
Peter,
lady.
you are the least lazy person in this room.
No, literally.
Oh.
Like, you're always locked in. Don't play.
I'm gonna be a smart lazy like Obi-Wan.
I've never had anyone do as much homework as you, and I really appreciate that.
He's calling you a nerd and a loser.
Opposite of what I just said. I said that
Hey,
y'all all gonna be
Serena,
working for him one day.
how many
That's what I
questions
said.
did you could write on the MCQ?
Oh.
14. Oh, wait, 13.
Yeah, that's what I thought.
Oh, you got 14 right because you actually read the question.
No, I got all of them right.
Oh.
I know, and there was
Okay.
14.
There were
Are we-
16.
No, I'm not.
There were 6. No, not. Oh, I thought you were talking about the progress check.
Hey guys,
I don't know why you asked that. No, they not.
I thought you were talking about the progress check. My bad, my bad.
please don't continue too much further past this point. I do want to show you all one thing. Hey, make sure you label it.
Yeah.
Do notice I created a separate table to make my life a little easier.
Why is it all
So you put it under the equals instead of you need it.
It didn't work.
Hold on. You put it under the equals.
Well, when I put it under the equals, it didn't work.
You don't put anything under the equals. You put it under A.
Okay, okay. I'm
You
doing
name it
Okay.
under A. You can just put
Someone
chips.
needs to take one for the team and eat 2 more Chips Ahoy cookies.
No, bro.
I mean, I'll eat 2 more. I'm not dissecting them though. That's hard. I'm good.
Okay,
I
that
ain't got time
defeats
for
the
that.
purpose. Mr.
Yeah,
Kenny.
literally.
Not
We're just
really.
being
I
big to be
mean,
big. You gotta be big with a purpose.
Like you.
Oh.
Yeah, I do have a purpose. I do have a purpose, excuse you.
Hey, do we have our data in?
Yeah.
Yes.
I'm trying. I can't really.
Then how about you not sit at the front of this group from the back?
No, I was talking about this.
I should have skipped right this.
I mean, I got it now. But I don't
It is a valid chip, so it is
No,
valid.
thanks.
Okay, I'm gonna have to go back with it.
It's barely new series, but it's
No,
something.
you can do an underscore or you can just put it as one word.
Okay.
Okay. Can we please watch Aladdin? Oh my gosh.
No.
Y'all are racist.
No, it's not racist.
I know you're not
It's,
talking about
it's, it's, it's called growing up. I had to suffer and do a play.
Y'all are racist.
I know you're
Play.
not
Yeah.
talking about being racist.
You were in Aladdin play?
Mm-hmm.
Ah, you're probably the genie thing or something.
Nope.
No, you're probably the lamp.
No, actually,
Were you?
my older sister was Jafar. Actually.
I need our data in.
It's in.
It's in. We're waiting for you.
You're not waiting on me, I'm waiting on others.
That's so weird.
Let's go. So, actually, let's do this. If you're still entering data, continue that. But what's the button I need to press to do cool stuff? Menu. Now, I want y'all to pay attention to something. So I'm going to show you something to make your life a little bit easier. Now, where are we going to go?
Statistics.
Statistics.
Confidence interval. Back.
So I'm going to do stat calculations to start. Yes, we're going to go to confidence intervals eventually, Peter. Hold on to that because I do want you to see something there. All right, so stat calculations and...
2 variable.
So we have
Wow.
two. Hold on. We have 2 lists, but how many variables do we have?
Oh, 1.
We only have 1 variable, the number of chocolate chips.
Oh, so
Okay.
you just increased the list.
So notice how many lists do we have?
Oh.
We have 2 lists, and so 1 variable is statistics, chips, a number of chocolate chips, but we have 2 lists. And so our first list is Chips Ahoy. The second list is
Dude, it will
Publix?
never change this.
I wish we could like touch screen.
Right.
Please.
well,
No, that's good.
doesn't exist yet. All right, first result
I'll
column.
make it.
Cable.
All
I
right.
keep this like this.
You're mean.
So do notice there are 2 columns here with data.
Columbine?
Okay.
What is wrong with you?
Sorry.
Okay.
Class.
Wait.
So notice we have our sample mean, we have our sample standard deviation. Go write that on your sheet, please. We have our sample
Wait,
sizes.
where'd my stuff go?
Yes.
We should all have those same values.
So now I'm
Say that again. Okay. Better run quickly. We're about to move to the next piece. Okay.
Oh, that's cool.
Now, let me see what the next thing in here is. Okay, so now it's asking us to construct and interpret a 95% confidence interval for the true difference in the mean number of chocolate chips cookies in Chips Ahoy and off-brand cookies. By the way, don't forget when we define our parameter, there's the parameter. What's the type of, when we choose our procedure, actually go ahead and fill in the choose. I'm going to give you all 90 seconds to fill in the procedure, confidence level, and parameter. Oh, did you forget lose a sheet of paper?
I didn't lose it. I know where it is.
It ain't with you.
Now, what's that?
Huh?
What's that? Like ice?
I mean, yeah, it's got ice in it. So, come on. Get a sheet of paper out.
No, like I was saying, can I get some?
There's a weird look about it. All right.
Because I was intrigued.
To that other thing, I don't mind.
God forbid you have curiosity. Like, it's his
You can scroll all the way up. They are the same.
Mr. Kenny, what did you come tell me to
Mean
do?
and sample standard deviation and sample size. Ma'am?
What did you tell me to do?
Write down the
No,
inference procedure.
I have ADHD undiagnosed, so I lost track.
No, that's not undiagnosed. You just don't listen to details.
What's our
I don't know
confidence
what I'm
level?
gonna say to that.
95.
If it's undiagnosed,
Oh, I
you
get
get diagnosed. And then you get a 504.
Publix and.
Yeah, they rejected me when I was little.
Jane finally did an autism
You can do
test.
it now, or you're old enough to go.
Yes.
Okay.
So I have to get a
So
reference.
that's been our 90 seconds.
I don't know.
Okay, so what procedure should we have here?
Two.
2 sample
To sample
T
T
interval.
test for difference of means.
What?
Oh.
T
No, not
test or
T.
T interval?
Oh my
T
gosh,
interval.
T interval.
T interval
Crash out.
for
For difference of.
True
confidence.
difference.
for a difference in, and you can just say means. Okay? Confidence level,
95.
95%. Oh my gosh.
What?
Parameter,
True difference of chocolate chips and CA and PX.
Yeah.
mu1 minus mu2, where,
YouTube?
yep, that is the true ... Right? So make sure you have the full context in there, the true difference in the mean number of chocolate chips in Chips Ahoy and off-brand. So I would say even mu sub CA and mu sub P. Any idea why I'm doing CA and P?
I didn't
Yes,
see
Chips
it.
Ahoy and T's Publix.
Right, so notice putting some
Yes.
context in my subscripts usually will count as evidence of understanding the parameters, okay?
You should do
Yeah.
Like on the test, like, or no, that kind
I would still
that kind
write,
of context, like-
I will still write more with it, but yes, that can count as context if it's something that makes sense for the context problem. I would still write. Okay, So it says assume conditions have been met. Which conditions are those?
Blah, blah, blah,
I'm confident
blah.
of melody.
I have no clue you just said, but sure. What'd you say, Dave? Can anybody help us out with Nate's saying?
I said no
Random. Now I need y'all to be careful.
Oh.
When you say random in this case, what do you mean by that?
Random
Random.
samples stated. Does it set the
You
samples?
said
are
random sample stated, but I don't have one sample. I have two samples.
Eh.
So what do I need to say?
This is the population distribution is approximately.
Well, I still know I'm on random though. I have how many samples?
Two.
Two.
Two
So,
random samples.
I have two random samples. There's another word in there that I need though. Starts with an I.
What?
What's the second
Independent.
one? What's the second one?
Say it again.
Independent.
Independent. Guys,
Oh.
I need you to remember the whole idea of combining distributions, right? When we do mu1 minus, or mu sub x minus y, all that kind of stuff, those rules only work when the samples or the distributions are independent of each other. So we have to acknowledge that it's two random samples that are independent of each other. We've got to keep that in mind. And I mean, is it fair to say that the number of chocolate chips in a Publix case is different, or is independent of what's in Chips Ahoy?
Maybe.
Yeah, they don't really affect each other very much, right? So you would have to say that though, that this is a random sample and these samples are independent. You got to talk about both samples though. 10%, can we say that those 24 Publix cookies are less than 10% of all Publix chocolate chip cookies? Same with Chips Ahoy? Yeah. And then, what about normality?
It said it in the thing that, yeah.
It said that the way that the process is done, it's safe to assume that the distribution is approximate.
What is that by, like in front of M, the first thing, what is that?
CA.
Two.
CA.
Okay.
CA.
Thank
That-
you.
Yes, Chips Ahoy.
Oh.
You said Chips
It's
Ahoy.
X1.
Mu sub P for Publix. Alright, now, if I want to run a test, no, not test, because we're not doing a test, a confidence interval, what can I do?
Menu.
Menu, statistics,
Confidence.
confidence intervals. Actually, sorry, pause for 1 second. I don't know why I'm jumping ahead of myself. We need to make sure that we're used to writing these things out. General formula for all intervals that have ever existed.
Statistic. Plus
Statistic. Plus or minus,
CV
critical value times
times standard error.
standard error. What's my statistic? We're dealing with means.
X bar. Oh, plus or minus T star times S over root N.
Really? You sure?
Oh crap. X
Oh, it's
X bar 1
1
minus
minus
X bar
X bar
2.
Ah, that's right. Chips Ahoy minus Publix.
Oh my days.
And I feel like we're missing something here then.
I don't know.
Yeah, that's a
I don't know my
different
formula
formula.
sheet.
Yeah, let's get that formula sheet out, ladies and gents.
I don't know.
Wow. Oh, okay, so it's.
They're alive!
Oh my.
Too bad you don't get the chocolate chip.
So y'all lost, right? Wait, where's the other ones?
I don't know what you're talking about. They'll beat me up.
What do you mean?
What?
You just made yourself look so guilty. You could have just said, I don't know.
They chose not to come. That's their choice.
Oh,
Alright,
Wait, he said.
right here. Hey guys, I need y'all to look at the formula sheet.
Yeah,
Oh
square
no.
root of S.
Sorry, you're kind of the only one who has their formula sheet.
I have mine over here.
I have my formula sheet. Don't do that.
Hey.
I have my formula sheet.
S1
And that's
squared.
surprising, so I need my credit.
Honestly, I am a little shook. Go ahead, sorry.
Okay.
Whoa.
Square root of S2 or S1 squared over N1 plus S2 squared over N2.
So notice this is again why we need to make sure we take the time in the choose to identify it as a 2-sample T interval, because now I know it for means, because now I know to go look at the means, I know it's 2-sample, and so there's my standard error, right? So that's all I have to write out there. Use your formula sheets. I cannot emphasize this enough.
Wait, pull it up again.
No, I'm writing it right here.
How many papers have we gone done? Where are we?
What?
This is the only one you guys can do?
That's all my-
Yeah,
that's
after
all I'm doing.
Chip which one. Thank you guys.
What does bold mean?
Pooled?
Between those.
Don't worry about it.
Huh?
What do you see?
Don't do it.
It's on
So you
like
guys do
the.
this?
I'll explain in a second. Alright guys,
We're going on that too.
I'll say this, write out your formula for sure. If you want to plug in numbers, you can. But I will point this out, do we even know what our critical value is?
Nah.
Do we know what our degrees of freedom is?
Nah.
I mean,
Oh wait, yeah.
I mean, we
No way we're.
Yes,
we do.
Combine it.
So we have, but here's the, and we need to recognize this. We have two different distributions that we're now putting together, and so we just have to figure out a way to combine our,
Sample size?
well, not our sample size, but our degrees of freedom. So, hold on, let me pull it up in the
Degrees of
textbook
freedom?
real quick.
Is it still
It's
minus
just
1 or
fun
is it
to
minus
have
2?
minus 1.
Wouldn't that be nice?
It's not.
Is it not?
I hate statistics.
Uh-oh.
Why is it not
So you
there?
guys like just.
I don't think y'all are ready for this.
It's gonna be some.
Yeah, we
it's
got
something
chocolate
goofy. I never been
chips.
to.
Chocolate chips.
It's gonna be like minus
It's
2.
the
or
way that
something.
he's holding the.
And we put it in the calculator.
Oh, because he doesn't remember it. And he's
Yeah,
gonna
there's
be
no
like,
way I would ever remember
Uh-oh.
this formula.
then he's gonna be like,
holy
then he's gonna be like, look on your formula sheet.
No, wrap it up, wrap it up.
Is on the
And this
formula
is
sheet.
on
No, no,
formula
no,
sheet.
no, no, no.
I was saying, do you see this anywhere on the formula sheet?
No.
Oh, my ditty.
It's right there.
Oh, it's
Mr.
memorized
King,
right here.
that?
Wait, no, wait. No, it's not. It's not. How in the world do they expect us to know?
I know, right?
Ah.
Mr. King, you know how to kill food for real. 'Cause what
Any
is
guesses?
That's just like
It
the
can be
standard deviation
simplified, or
squared
it's on your
over.
calculator or something, right?
Is a number.
Right?
It can't be.
There's something with technology that makes our lives a lot easier.
Maybe. Alright, so let's look at our T interval. Okay, now first off, I went to T interval. I don't need a T interval. We need a what kind of interval?
Two simple T.
We need a 2 sample T interval. So confidence interval, 2 sample T interval. And let's go ahead and put in statistics for now. We already have it written out. I'll show you the difference in a second. Alright, what's our first mean again?
Okay.
19.25.
19.25. What was that standard deviation?
4.6.
4.65.
Sample size?
8.
8.
What does that?
What was that, 30 something?
35.4.
35.4?
Yep.
Oh, okay.
Said 9 point something?
9.91.
Oh, wait, we gotta
10.
slow down or something.
Hey, Sanaya, it's on the sheet of paper.
No,
Like
I
the
know
values.
that. Is the B supposed to be there? Because I feel like I actually pressed this.
Huh?
Is this supposed to be there? Because I feel like I actually pressed this, picking it up.
Ooh. Oh, this is where you talk.
Yeah.
No. Just kidding.
I don't know.
Wait, so S,
Um,
S
do I
is
want to
standard
include a-
deviation.
Standard
right?
deviation, okay. So confidence level, what confidence level do we want? 95%?
95.
Alright, notice right here, it does ask this question of pooled. One, I'm gonna leave it up to you to read in the textbook. It's supposed to go onto your FAIR model. I can go ahead and tell you this though, don't ever pool on the AP exam.
What's X? What is
Pooling your data is something that we do when we assume that the variances in both populations are roughly the same.
I feel like you've gone over this.
So don't pool your data.
Do we leave the top blank?
Huh?
How would you know?
Don't, that's why I'm saying don't pool it. Pooling only works in that case, so don't pool your data.
Mr.
Why
Kenny,
would you?
Ma'am.
what's on the top? Nothing?
What?
What do you have the first three?
It's on
It's on your sheet of paper, isn't
What sheet of paper?
She doesn't
This-
have a sheet of paper.
He knows that.
it? Did you not write the data down?
I did, but I don't have those numbers.
I would like to also see the data.
Well, I'll show it later.
I'm
Okay,
lost. I'm just gonna have to
So
follow.
what benefits is there
Okay.
to pooling?
great question. Oh, so actually, I do know that answer. Pooling and also what is called using a conservative value was good when we didn't have calculators and technology like we do today. Alright, so look at our confidence interval information. This looks kind of exactly what we would see on a calculator page, doesn't it? Yeah, that's good. So we have our confidence interval. We have the difference in the means. We have our, what's that ME stand for? There's my margin of error. Ah!
What the freak?
There's my degrees of freedom.
What the freak?
Maybe I don't have to calculate it by hand. That's nice.
I'm not doing that.
Yeah, I would never, ever, ever. I did memorize that degrees of freedom formula when I was a first year AP Stats teacher, and that was a mistake because I live in the 21st century. Yeah, no, we don't memorize degrees of freedom formulas.
So what
We
you're saying
use-
is you're stuck in the past.
So that's the,
Used to be? I'm a bigger nerd today than I was then. I just thought I had to.
so that's
so you were
this on the
tryhard.
formula sheet?
No.
Sounds like, that sounds like.
I'm so lost.
That's your standard error formulas, right?
Okay,
Oh, math.
That's degrees of freedom.
You had a coda?
why am I looking?
Coda?
Alright,
Skew to spread.
Oh.
so please notice they have all this data down here as well, okay? Now, so as I was saying though, degrees of freedom, so I cannot look, it doesn't tell me my t-value on the calculator, does it? But it tells me my degrees of freedom, what is it?
13.
13, okay, so if I pull up the t-distribution chart, hopefully you have one easily within reach.
The one with all the numbers.
Did you say?
So if I look at the
Oh, I was just.
t-distribution, okay, so I need what degrees of freedom?
Oh,
13.3
I
is
have
not on
that
here.
one too,
You
distribution.
just said
So-
13, round down.
Yeah, we round down, right? So 13.3, so we go to 13, and what confidence level?
95.
95%, so
2.16.
2.16, there's my t.
How did you get reading glasses?
So, please hear me clearly. Do not memorize degrees of freedom for 2 samples, right? Degrees of freedom when it's 1 sample is what? N minus 1. There we go, thank you. Degrees of freedom for 1 sample is N minus 1. The calculator will do degrees of freedom for 2 samples for you. Yes, Nate.
Calculator direction.
I like the wind bullseye.
Is-
Or ride like the wind. Sorry,
Wait,
Jay.
what?
Yeah, go for it.
He's not even
Why
in
is it so
here.
complicated?
It's irrelevant.
Huh?
Why does it have to be so complicated?
I'd have to do some more research on why it's that complicated for the degrees of freedom formula. I don't know that off the top of my head.
Is there one for 3?
Say again, sir?
Is there one for 3?
Ooh.
For 3 means?
Yeah.
It's beyond the scope of
I
this
did it
course.
myself.
But yes, there is.
I'll take this.
There's multivariable.
Does it
statistics.
I'm ready for myself.
Yes.
So is this the interval one?
Yes. Lower part of your interval, upper part of your interval.
Actually,
We're gonna look at this. Okay, hey, pause 1 second. What I do want everyone to quickly do is, I want you to add a new page, a calculator page. And by the way, Sanaya, even if you didn't write it down, all that data was still on your calculator.
But that would mean I have to go back.
Then write it down. Okay, so here,
Oh my.
menu, I wanna do the interval again. Where am I gonna go?
Statistics.
Statistics,
6.
confidence intervals,
664.
and then 2 sample t interval. You could just call it what it is, don't just yell out random numbers. 2 sample t interval.
Memorize it.
Now let's do it as data, but here's the thing, you don't have to memorize, you can just read. Alright, let's do it as data this time, hit OK. So what's my first list?
What the day?
Chips Ahoy. List 2, Publix. And notice,
Why don't I have that?
Wait,
did you do 2 sample t interval and
No, I
data?
have that, but I don't have the data.
Did you not name the variables?
I did. I don't have any data at all.
That's because you're on a scratch pad, not a calculator page.
What?
That makes sense.
That's a scratch pad. We want to go back to our document. You control
out.
doc to add a page, add a calculator.
Oh, I didn't know I could. I got
Yeah,
it.
mhm.
Okay. Thank you.
Okay, so hit enter.
It's the same.
it's okay, I just.
It's the same junk. That's wild.
What do you do for freaking first of that?
Yeah, what do I do with frequency?
One. So literally what that frequency is how many times you're using that list, you're using each of those lists one time.
Okay, and the C level section.
Confidence level is 95%, 0.95.
Can the calculator
I don't think
read?
I did it right, but I'm just trying to, can you like explain?
Wait, I'm on
We're gonna talk about that. Yep.
Because I don't think
I know.
Why would
Okay.
It's so weird.
So, we got our, so you can substitute your numbers in. I'm not going to right now, but take the time to substitute those in. What was the answer we got? Negative
23.6,
0.76, comma.
negative
8.52.
Now remember, that's a confidence interval. And what we did is we took the average number of Chips Ahoy cookies and we subtracted the number of Publix Chips Ahoy cookies, right? The average?
So there's convincing statistical evidence that the.
Wait, we haven't even interpreted the interval yet. We're not talking about convincing evidence. Convincing evidence is for a what?
Test.
Hypothesis test. We're just talking about interpreting the interval.
Why not?
It's at the bottom.
With
Fake.
what?
95.
With
95% confidence. The what? The interval from negative 23.76 to
Negative 8.52.
8.52 chocolate chips, because that's what that is. Does what? What is that interval doing? Captures the true, not mean difference, the true difference in means. This is actually going to be very important. I need you to hold on to this. This is a difference in means. There is something called a mean difference that we're about to look at in the next lesson. So hold on to that. That's where the paired data comes from. Okay? Captures the true difference in means. And you can see it in the formula. So pay attention to this. And notice how I'm taking a mean and then finding the difference. So it's a difference in means, difference in two means, right? So captures the true difference in means,
Between the
or
chocolate
in
chip
mean number of what?
chocolate chip,
Chocolate chips,
pull bread.
chocolate chips, cookies versus, or chocolate chip cookies for Chips Ahoy.
Wait.
Yep, thank you. That's why you always go back and read after you finish writing, because gosh, you can get lost. But number of chocolate chips
per cookie
in
Chips Ahoy and
Chips Ahoy versus Publix. One thing I will make a note of, I at the end would put mean of Chips Ahoy minus Publix. That way you're very clearly communicating that it's Chips Ahoy minus Publix, not the other way around.
Oh, I probably did that wrong on my FRQ.
So be careful with that. What I will point out is, the reason why that's important is, what is this interval actually telling us? Like, this is how we interpret it, but what does this mean?
That the
It means
that oh my gosh.
that P2
It's not-
is greater.
Yeah.
Okay, so everything being negative means that the mean of Publix, mean number of chocolate chips for Publix is greater. That's why this entire thing is negative. So
So it's not plausible for Chips Ahoy cookies to have more chocolate chips.
it is not plausible for Chips Ahoy to have more chocolate chips. It's also not plausible for Chips Ahoy and Publix to have the
Equal.
same number of chocolate chips, right? So I know it's really freaky looking at both those being negative, Lana, but that's why we need to recognize, like, all that that's saying is Publix has way more, right? We are taking a smaller number and subtracting a bigger number. Publix has more chocolate chips
Okay,
with 95% confidence.
so could you do it the other way around?
You can do Publix minus Chips Ahoy as well, and you would give us all positives. So let me ask you this. Does this provide convincing evidence that there is a difference between Chips Ahoy and Publix? I think that is the next question, is yeah.
Oh, there is.
Yeah.
That's not the point of this. The point of this is to find, to provide an estimate for the true difference. By the way, on your test and on your AP exam, you better make sure that you are clearly communicating the population, not a sample. There needs to be something about the population mean, the true difference, the population difference. I don't care, but you gotta talk about the population in some way when interpreting, when defining your parameters, the whole nine. Yes, Sanaya.
May I quickly use the restroom?
You better run like the wind. Rock like the wind.
Dude. Get it
Alright.
right.
So, does that make sense though, Lana, why it's negative now? So yes, you can always flip it. And I will say, if you look at your data and you find those averages, and you're like, man, this one's bigger, and you like to have positive numbers, you can make this 1 and then this one 2. Yes, great.
So as long as the interval doesn't include 0, you can say that it has convincing evidence that there is a difference.
Thank you for
As long
correcting
as
it.
it doesn't
Don't,
have 0.
as long as it doesn't have 0, and also make sure it
Not
doesn't capture
prove
0. Not prove
convincing.
convincing evidence. That's something that also got somebody else. It's all about, do we
Supports.
have convincing evidence for the alternative?
Can you say it supports it?
Yes, but it doesn't just support it, it provides convincing evidence. Because here's the thing, the mean of, what was this mean?
I don't know.
35.4
and 19.2.
and 19.2? 19.2 and 35.4, that supports it, right? But is it convincing?
No.
Not until we do a test or we do a confidence interval. We need convincing evidence. All right. So do we have convincing evidence that there's a difference in the average number of chocolate chip cookies?
Yes.
Heck yeah, we do. All right, confidence intervals for a difference in means. Let me check one thing to make sure that I am remembering all the big ideas we're supposed to talk about here.
So
Okay,
what have you
yep.
guys done today?
That's exactly what I was thinking. Say it one more time.
What have you guys done today?
We ate cookies.
We ate cookies.
Is that it?
We did the 10.2 check your understandings all together. Okay, so
Okay.
if I'm doing a confidence interval for a difference of means, I need the 4C method of inference. Ooh, one thing I did just realize is, so again, make sure you go through the choose procedure. So this is a 2 sample, what kind of interval? T interval for a difference of means, okay? So we got to keep that in mind. Second, within the choose, got to have your confidence level, and do not forget to do what with your parameters?
Define it.
Define the parameters. If you're going to say that it's a difference of means, you better write out mu sub 1 minus mu sub 2 and define what mu sub 1 and mu sub 2 are. I will make that note, and I said it in the video that I worked some problems out at home. Personally, I really do prefer just saying mu 1 minus mu 2, and then mu 1 is this, mu 2 is this. Or mu, yep. You can say mu sub CA for Chips Ahoy and mu sub P for the mean number of chocolate chips for Publix. I like that language better. I think it flows better. But if you want to do mu 1 minus mu 2 is the true mean difference in blah blah blah,
I love mu
you
2.
can. Alright, so choose. Be careful with this next part. Check. How many samples do you have?
2.
So how many samples need to be random? 2. And don't just put random and check. That is like the bare minimum. They sometimes don't count that for evidence. So you need to talk about 2, not just random, but 2 independent random samples. You got to talk about that. A short little sentence will do wonders. You got to check 10% if sampling without replacement. Let's say it this way. N is less than 10% of N. And then don't forget how many how many samples do we have?
2.
2, so how many samples need to be approximately normal?
Dose.
And ooh, I said that wrong. It's not samples are approximately normal.
Sampling.
Sampling distributions need to be approximately normal. So you've got to check both samples for approximately normal sampling distributions. And I will always bring it up, if they tell you the population is approximately normal, the sampling distribution is approximately normal, but man, that's very rare to actually happen. Okay, you can have, as long as you satisfy central limit theorem or the sample is not heavily skewed, you're going to be good. All right, after check, calculate. Please understand how to use that calculator. When you go to pick your inference procedure in the calculator here, make sure you go back to this. Or if you're even stuck in figuring out which procedure to use, go to the calculator, hit menu, and okay, first of all, am I doing an interval or a test? Okay, look at your intervals. Which intervals do I have? Do I have a mean or do I have a proportion? Because that's going to tell you a ton. Use your calculator, use your name up here to help you figure out which procedure. Think through those details. But general formula, then your specific, etc. For T, are you ever calculating that by hand? Nope. T critical value, let the calculator do the work. Do we pool our data?
No.
Do not pool the data. You can read a lot more about it in the textbook, but we don't have time for that. And then what comes after calculating? Concluding. Go back to the way we've always interpreted it. Okay? We are this confident in blah blah blah. This interval capturing the parameter, these plausible values.
Dude, I thought that was some throwing up.
Oh my gosh.
That would be Mr. Olson.
Oh, that was him earlier, wasn't it?
Yeah, he sneezes like 30 times in a row.
That was like
Oh,
a girl
like
sneeze
consistently.
though.
Yeah,
That's
that's
alright,
that's
not
not
Mr.
good.
Olson.
And then Sprague, this goes to what you were asking earlier.
Does it?
I have no space.
Alright.
Yeah, I don't have room for this, John.
Oh my god, we're still going.
If they're both negative, what does that tell us?
Two is bigger than one.
Convincing evidence.
Convincing evidence
Yeah, whatever.
that mu, which mean is bigger? mu2 is bigger than mu sub 1. You can also say it the other way, right?
Could you just do like mu and mu2 instead of mu1 and mu2?
Whatever you want to do.
No, you say it.
Wait, that's not,
Alright, they're both positive.
that wouldn't work.
Yes.
mu1 is bigger than
No,
mu2.
mu is bigger than mu2. Yeah.
Convincing evidence mu1 is
That's
bigger
not
than
right,
mu2.
Serena.
What?
Okay?
Me2's bigger than you.
Oh, okay.
Man. What if one's positive? Ooh, first off, please don't ever do this. What's wrong with this interval?
That's.
Hello?
Yeah, the minimum goes first in an interval, not the bigger value. So a negative and then a positive. If that's true, what do we have?
No convincing
Convincing
evidence.
that there's no difference.
We do
No.
not have convincing evidence there is no
Either.
difference. Be careful, and I'm
Because
glad that so
zero
I'm
is
asking this.
included.
There is not convincing evidence of a difference. Okay? We don't know that there is no difference, we just don't have enough evidence there is. Right? Remember, we have convincing evidence for the alternative here, that there is a difference, but there's just no convincing
Bless
Okay.
you. You like built up to
no
that.
Go for it, I'll
convincing
bet you
evidence.
So even if it has like a bunch of negative values and then just like barely any positive ones, just because it like includes both, it cannot be convincing.
Yeah.
Okay.
We need to recognize that, because what that is saying is that even if the majority are negative and like it goes to 0.0001, is 0 a plausible value?
Yeah.
I've
Okay.
been doing research and then saying that.
I know, it's frustrating.
I'd crash out.
Yeah. Alright.
Then I'd probably like increase my, no, I'd decrease my yeah.
Yes.
What are you talking about?
I'd decrease my confidence level in order to get a
Or you could do it, recollect your data and collect higher samples.
I do it all.
Alright,
I do it all.
just check your understanding. We do not have time to go over. If I were you, I would do it. I will post a video so you can check it, and then you can, what's the word I'm looking for? You can ask questions tomorrow before we start class. So, do your check your understanding. Where's my remote? No one knows. Cool. Alright, so the next one is climate change real? It's a really cool lesson.
Yes.
We ain't got time for it.
every single
Oh,
time that Peter
So,
queries.
what we're going to
the
do
final
instead is this. My question posed to you is, what is the true difference in mean time spent on our phones
So the screen
for
time.
the weekend and a weekday?
That's what you want to do instead.
Yeah, that's what we're gonna do instead.
That's boring.
I mean, isn't it just a random?
Oh, the Sunday, Monday data we already collected. That's right. That'd be really convenient to help us assess
Is
this.
this not the
This
how
is
much
weekend.
screen time thing?
It- so-
like,
The how much screen time only looked at which day?
Sunday.
Sunday.
Okay.
Today, we are looking at not just Sunday, but Sunday versus Monday.
Do we have a paper
Monday.
for that?
the whole week. It's like-
And don't worry about that. It's a random Sunday and a
Okay.
random
Oh, so
Monday.
this happens-
Yeah,
okay,
yeah. Okay.
That's not.
Is it,
It is.
what is the probability of that? Or
Yeah,
more
not-
extreme?
Yeah, uh-huh.
Uh-huh.
Maybe I'll play better in the future. Okay, so here's what I want us to do. So here's my Sunday screen time stuff. Here's the data. I only have 8 data points. I got mine and Miss Kowalski's and 6 more of you. The other three of y'all hate us, got it.
Who's
Oh.
1,048, I'm curious. Michael?
Jade.
No comment.
I know who it was.
Wait.
Is that yours?
1,048 minutes in a single day?
How many
No.
hours is that?
I got a child, first
Oh, I
off.
think that's mine.
No,
It
it's
is.
disgusting.
It's Sanaya's.
It is not Sanaya's, I don't have
It's
your
not?
up here.
It's
No.
not.
I put my.
Is it Jaden's?
No.
Jaden had 17 hours, so it could have been him.
He's a loser. I'm sorry.
He had 5 hours on that stupid game that
I
Mr.
feel
Kenny
left
showed
out
him.
Balatro is so good though. It is so great. Alright, so here's what I want us to do. Okay, first things first. We want to compare this, and I couldn't remember, Sanaya, which data point things went with, but I want y'all to see this. So what are we first going to do if we want to try to find the true difference in mean time spent on our phones for the weekend and weekday?
The
Thank you!
Oh.
I'm so glad you didn't say jump to the calculator. What are we going to do first?
4C.
The 4C method of inference, right? So what's the first thing we got to do? Choose our procedure. It's a what?
Two samples T.
2 sample T interval for a difference
in
in means, right? Difference in means, okay?
Difference in means.
Difference of means in means, whatever. Okay, so confidence level, what confidence level should we do?
Probably 95.
Probably 95, that's pretty standard, right?
Okay.
And then define your parameters, and we would check our conditions, but we're not gonna do that because that would not be good. Check our conditions.
Oh, okay.
Not really random. Now, is it less than 10% probably of all Sundays and Mondays? Or
It
weekends and weekdays?
It
Should be. Now, I will say this. What condition should we probably check and get a little bit of practice with real quick?
Approximate normality.
Approximately normal. So, do we have enough data to satisfy the central limit theorem?
No.
We definitely don't. So, what do I need to do?
Oh, we can graph.
Look at the graph.
Let's look at the graph of this, right?
It does look a
Control,
little skewed.
add page. We don't know yet, though.
And we just
Okay, I'm gonna add data and statistics. So remember, part of the beauty of putting our data in like this is if I add a data and statistics page, I'm gonna do Monday up.
Okay.
Does that look heavily skewed?
Nah.
No, we have like those 2
Let's-
data points
Wait,
that are
wait, wait.
stacked,
Let's
but,
go to Sunday. Let's go to Sunday. Not all of them are on. Oh, never mind.
well, let's also change our plot type.
Real.
How do you believe page again?
I don't
yeah,
even know.
So box plot, you don't need a delete page, just create a new one. I can show you how to delete later. I will say this, it doesn't look super heavily skewed, does it? Did I ever start recording this again? I sure hope so. Oh, I did, sweet, okay. So it definitely doesn't look too heavily skewed. Now, yes, that was Monday, let's look at Sunday. Because we do have some interesting people
Wait.
in here.
Teamwork.
It's a little more skewed than we probably want, okay?
Yeah, I don't
Oh.
think that's approximate.
Okay, now, hear me clearly on this, and they say this in the book, and this is accurate. The AP exam wants you to run a procedure, okay? If they ask you to do a procedure, and just, if you think things look a little wonky, make a note of, hey, this looks a little bit more heavily skewed than it should, so I'm gonna continue this procedure, but take the results with caution,
With
right?
a grain
It's
of
not
salt.
100%, okay? Now, going back to here though. All right, we checked our conditions. Of course, we're gonna write our formulas, do the whole 9, but now what do I need to do?
Calculate
Menu,
that junk.
and go to statistics,
Stacks.
stack calculations, right?
If you want.
Trying to do a confidence interval here, guys.
I don't have that. Is that supposed to be on my calculator?
You don't have your hat on, so you didn't get a chance to log in.
Oh.
No.
Yep. All right, so where are we going now?
4.
2 sample T interval.
Wait,
Do we
guys,
need to
hold on.
enter statistics, or do we have the raw data?
We have the data.
We have the data, so we can use data. It's gonna be a little bit easier. List 1, Monday up, that was Monday updated because I changed things.
Oh, gotcha.
And Sunday updated. He's alive!
Oh,
Come along, sir.
Where's all the Chick-fil-A at?
Okay,
Why do you have the whole?
Wow, look at
Why do you have the actual
right here,
bag?
guys, right here. Okay,
I know you
are we
like.
gonna pull our data?
No.
No.
That's silly.
Hit okay. Alright. So, is there convincing evidence that there is a difference between the amount of time we spend on our phones for the weekend and the weekday?
No.
What's on his arm?
Why not?
It said Mr. Kenny sucks.
On his arm.
Bro, who wrote that? Guys, right here, I've got 6
No.
more minutes. I need your attention.
No.
Is there convincing evidence of a difference in our amount of time spent
No.
online?
Oh.
No. Right? Jaden down. You can't show up this late and start talking. I need us to focus
The teacher thing was
right here. Why is there not convincing evidence of a difference?
Because-
There's a negative
Because
and
zero's
a
included.
positive, so there's a possibility, even plausible value of zero, right? What we did is we calculated an interval for the mean of Monday minus the mean of Sunday, okay? And so there's a value of zero in there.
I was gonna do
Now-
repeats, but I guess not.
I did Monday first.
Yeah, I was thinking.
Yeah. Yeah.
No, I want chicken.
Alright, so notice though, again, same thing, you'll just get opposite values. Now, pause for a second, I need y'all to pay attention to this. Please notice over here, the person who spent 1,000 plus minutes also
I hate
spent
those.
600 minutes on Monday. The person who only spent 550 minutes on Sunday spent 485 on Monday. Someone who spent almost 900 on Sunday only spent 300 on Monday. So there seems to be a pattern where overall, except for this one person here, people who spent more time online Sunday spent more time than others on Monday, right? And I have this set up as a paired, so this is the same person, this is the same person, this is the same person, etc. So do you see how these data points can be paired together? So instead of doing a 2-sample interval, let's actually take the difference of those first. So, those pieces of data are paired up. Now, what I'm going to do is I'm going to go here, just focus up here real quick. So, equals, to stay consistent with what I did, Monday minus Sunday. Don't worry about it. Just focus up here for a second. So, there's my mean differences. Notice, it seems that we spend more time on what day?
Sunday.
Online, on Sunday, and a whole lot more time. Okay, so let's run an interval this time. Now, when I do my interval this time, what type of interval do I need to do? I need to do just a simple t interval. Hear me on this again. Because I found the difference, which let me also actually name this. So, difference, okay? Because I did the difference, how many lists do I now have?
How do you do difference?
3.
I'll show you, hey, pause for a second. Train, just focus up here. I'll show you how to go through it again. But all I did was I did the difference. I did Monday minus Sunday, and it filled it in for me. So how many lists do I now have?
3.
One.
What?
For just a one difference, don't I?
Oh, okay.
Yeah. So what type of interval do I want?
T.
I want a t interval. And I have data. And so I'm going to put my difference in now. Notice that one is a lot cleaner. And so now my first result column is going to go into F. And I need you to look now. Do I now have convincing evidence that we spend more time online on Sunday than we did on Monday?
Yes.
Yeah, very much so. What's the difference? Notice this mean is the same as this mean, right?
Is that you have the difference of them? So-
Yeah, well, so what happened? What happened? The margin of error was what? It was shrunk. Because remember, when we have a 2-sample thing, don't we have to look at adding those two variances together? Isn't that crazy? So what is adding, or when we combine random variables, that chaos always what? Increases, right? Like chaos and variability always increase. They add it together. But here, now I only have one sample.
What?
So if you have data that can be paired together, that's called paired data. And we find the difference first.
Is this the stupid match pairs thing?
Yeah.
This is a matched pairs design, okay? So notice, I put Jaden's data with Jaden, I put Nate's data with Nate, and so by blocking essentially, I want you to think about that, that's essentially what we did. We blocked on that one individual person that reduced our variability. So when you can put the data together, you can take a difference first, and it now becomes just a one sample. So remember when I said earlier, difference in means? That's because this is the idea of a mean difference. So when you do a paired set of data,
Oh, like the mean
that you are doing a mean difference, a mean of the differences, whereas if it's 2 samples, okay, that is going to be a difference in what? Means. So if you can meaningfully pair the data together, as in it's Jaden and Jaden, it's Sprig and Sprig, it's Serena and Serena, then you
it's
can
the
find
first
a
one
difference and a mean of the difference, huh?
So is the first one Jaden?
Maybe.
Cause I'm the second
maybe.
one.
So difference
It
in
was,
means.
you had like
okay?
1,000 and everyone
Yes.
else had like
what if
600.
we pair them, but it doesn't?
No way.
That's
So
16
don't
hours.
pair them
I
unless
remember
they're
one.
meaningfully
I'm
paired.
not
Nine
gonna-
hours.
Right, so the fact that
Yeah,
like I have Jaden's data and Jaden's data from Sunday and Monday, then I can
1,000?
meaningfully subtract them. But it would make sense to pair his data from Sunday with your data from Monday, right? So if you have two sets of data that can be very clearly linked, it's paired data, and you're gonna do your difference first, and then do a T interval for paired means.
No, I can't read
If you can't meaningfully link them together, then you just do a difference in means. And the, I will say the main difference, like it makes it easier to find convincing evidence, because we reduce our variance.
I thought you had like chicken nuggets.
Does that make sense? So that's the big, we'll do continue working with it some. I will do like the final notes tomorrow on this, but definitely do check your understanding for 10.3. We'll do a couple of final details on that, and then we'll get out and we'll start on hypothesis testing tomorrow. Hey guys, hear me on that, we're starting hypothesis testing tomorrow, so DYU is gonna be on Monday.
Okay.
For confidence interval with means. And if you want to look at your tests, you can. Most of us are going to want to do a retest in the kindest ways.
What?
Well, I had one 100 and then I did not.
What was the second
Wait, did I
one?